Alright, this video is just for extra practice on solving equations and then some vertical motion problems afterwards. So the first 5 problems are just going to be solving for x. Now the thing is now you have a toolbox of different strategies for solving. You can solve by square roots, completing the square, quadratic formula, and of course factoring when it can be factored. So basically I'd like you to try number 1, 2, and 3 while they're sitting in front of you. Go ahead and pause the video and try them on your own, and then we'll talk. I'll talk through them so you can see some strategies. Go. Alright, so for number 1, when you're solving, one thing you might want to do really quick is get everything on one side to see if it can be factored. So we can make this 2x squared minus 12x plus 18 equals 0. And we can factor out a 2, leaving us with x squared minus 6x plus 9 equals 0. And you should see right away that you can factor the inside. So this is x minus 3 and x minus 3, which is x minus 3 squared, of course. So then all you have to do is say that x equals 3, and you're done. So number 1 is a perfect opportunity for you to just factor to solve. Now, can you use quadratic formula? Of course you can. Can you use completing the square? Yes, you may. But it's sometimes you want to use the strategy that's going to be the quickest for you for quizzing and testing purposes. Number 2, you can see that it's already set up to solve by square roots. All you have to do is divide both sides by the -4. That's going to give you x minus 7 squared is equal to a -25. Square root both sides, and you get x minus 7 is equal to plus or minus 5i. Add the 7, and you get x is equal to 7 plus or minus 5i. And you're done. So try to use the most efficient strategy that you can. Okay? Let's continue to number 3, and then I'll let you have more time to try number 4 and 5. So number 3, again, try bringing some stuff over. So x squared minus 2x plus 5 equals 0. And now ask yourself if it can be factored. So can you think of anything that multiplies the 5 but adds to a -2? No. So now what do you want to try? Do you want to try completing the square, or do you want to try the quadratic formula? I say, since there's no number in front of x and you don't have to do anything fancy, for this I would say use completing the square. So bring that 5 back over to the other side. Leave a little space. And half of 2 is 1. Squared is 1, so add 1 to both sides. And then we can write this as a square of a binomial. So this is x minus 1 squared is equal to a -4. And now square root both sides. And you get x minus 1 is equal to plus or minus 2i. Add your 1, so x is equal to 1 plus or minus 2i. Again, you could have used the quadratic formula for that if you like that better, but it's nice to know when things can be done in the more efficient way. Okay, so here's number 4 and 5 for you. Go ahead and pause the video again and give those 2 a try. So for number 4, what you want to do is you have 2 terms. They're both perfect squares. There's a minus in between. You've got 4x minus 3 and 4x plus 3 equals 0. So x is equal to 3/4 and a -3/4. Or if you prefer, x is equal to plus or minus 3/4. Either way, same thing. And so that would be definitely the fastest way to do that, unless you wanted to do solving by square roots, because you can take the square root of 9 over 16. It would work out to be 3/4 as well. Number 5, get everything to one side. 18x cubed plus 12x squared minus 8x equals 0. And you can factor out a GCF of 2x. So we have 2x, and then we have 9x squared plus 6x minus 4, which is equal to 0. And then you might think that you can do Batman, or box method, splitting the middle term, guess and check, but you're trying to multiply to negative 36 and add to 6, and it's not going to happen. So then what else are you going to do? Well, you still have your 2x, which you can just set equal to 0, so you know x is going to be equal to 0. But now you still have to take care of the inside. And this, with the size of those numbers, if I were you, I would use quadratic formula. Because if you tried to complete the square, you would have to factor out a 9, and then you'd have 2/3 for your terms of x. You'd have to take half of 2/3 and square it, and you're going to be working with nasty fractions. So, use the quadratic formula. Opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a, and just work it out. So you're going to have a negative 6 plus or minus the square root of 180 on the inside all over 18, and that's going to give you a negative 6 plus or minus 6 root 5 all over 18. You can reduce the 6's and the 18, so you're going to want to split it up, and that's going to be x is equal to negative 1/3 plus or minus root 5 over 3, comma, 0, because you cannot forget your 0 from earlier. Okay, he's still part of the solution. Alrighty, so that's how you do number 5. That's just some warm-up problems on how you solve. Just use your entire toolbox. Use the best method at the best time if possible. And sometimes you might have to try it. Factoring is definitely the fastest if it can be factored. But if it can't be factored, remember your other possibilities. Okay, so now we're going to get to some vertical motion problems. So you have two different types of models for vertical motion, and one of them is negative 16t squared plus h sub 0. H sub 0 is your initial height. Regular h without the sub 0, that's your final height. And then you have negative 16t squared plus the initial velocity, that's the VO, t plus h sub 0. Now, if something is just dropped, there's no initial velocity. It's just sitting still. But if you throw something, that's your initial velocity. If you throw it up, it's positive. If you throw it down, it's negative. Okay? So, something to keep in mind when you do these problems. So let's see what we're going to do. Here's a little note, side note for you. If you throw something up, like I just said, it has a positive velocity. If you throw something down, it has a negative velocity. If you throw something straight out in front of you, parallel to the ground, it actually has 0 velocity for the up or down. It's just going to go straight out. So it's the same as dropping. Okay? So, let's go. The tallest building in the United States is in Chicago, and it is 1,450 feet tall. How long would it take a penny to drop from the top of the building? So, keyword, drop. So you are going to use your drop formula, which means the final height is equal to negative 16t squared plus your initial height. So then 0 is your final height, is equal to negative 16t squared plus your initial height of 1450. And now from here, you just have to solve. Check it out. You've got a t squared, no t, just solve using square roots. Subtract that 1450 to the other side is equal to negative 16t squared. Divide both sides by the negative 16, and you're going to get t squared is equal to 90.625. And then all you have to do is take the square root of that, and you're going to get t is approximately 9.52 seconds before it hits the ground. That's quite a long time to drop a penny before it hits the ground. Okay? So, how fast would the penny be traveling when it hits the ground if the speed is given by S is equal to 32t, where t is a number of seconds. All you have to do is take what you found in part A. So S is equal to 32 times 9.52, and you're going to find out that it is falling at 304.64 feet per second. That's pretty fast, y'all. Okay, so number 7. I'm going to actually tell you to try number 7 on your own, to at least set it up, and then we'll go through the solving process. So read carefully and check back in a second. So before you solve, check to see if you have it set up correctly. Here's the thing. Your final height is 6, not 4, because it says that the basin is 4 feet below the spout, which means if the spout is 10 feet off the ground, the basin is actually 6 feet above the ground. So from here, all you have to do is solve. So if you had a 4 instead of a 6 for this part, make sure you change it to a 4 and try solving. And from here, all you have to do is this. So you have your negative 16t squared plus 30t plus 4 is equal to 0 after you subtract the 6 to the other side. You can factor out a negative 2 here, and that's going to leave you with 8t squared minus 15t minus 2. And from here, all you're going to have to do is, again, if you would think about trying to factor it, it's not going to work in this case. So what you want to do from here, actually I'm kidding, you can factor this using Batman if you want to, or use the quadratic formula. So then just pick a method, and as soon as you're done solving this, if you want to use quadratic formula, I'll show you that it's going to be 15 plus or minus the square root of a negative 15 squared minus 4 times 8 times a negative 2 all over 2 times 8. Once you finish that part or simplify it, it's going to be 15 plus or minus the square root of 289 all over 16. The square root of 289 is 17. So you have 15 plus or minus 17 all over 16. So remember, you must add and subtract. So you have 15 plus 17, which is 32 over 16. And you have 15 minus 17, which is negative 2 over 16. So you're going to have times of 2 seconds and negative 1/2. Well, can time be negative? Nope. So it takes you 2 seconds, because negative 1/2 is not a realistic time. There you go, 2 seconds for it to go from the spout to the basin, and that is vertical motion. Remember, vertical motion with a velocity, you need the VO times T. If it's just a drop or a horizontal throw, you do not need it, and you can just use the drop formula. All right, this is Longo, and I'm out. See you, bye.